If you recall, at the beginning of the course, I mentioned the prerequisites for the course and mentioned that they include a basic working knowledge of the shell. Well, there are some features of the shell that are not entirely what you might call basic, that are absolutely essential to the business of writing shell scripts. I would hope that people are familiar with them, but I can't assume it, and so I'm going to take out a little bit of time, and in this module I'll just make sure that everybody is aware of them. There aren't many of them, and it shouldn't take too long, so let's have a look at that. The first one is the feature of the shell that allows any of the standard output of a program to be redirected to a file. An example of that is if you run the command called who, and then you put a greater than sign after the who, and then after the greater than sign you put the name of a file, then all of the output of that program will be what we call redirected into that file. It would normally, of course, appear on the screen. If the file already exists, it is overwritten. If the file does not exist, it is created. Now, whether it's overwritten or whether it's created, you actually have to have permission to do those things. To create it, you have to have write permission on the directory, and to overwrite it, you have to have write permission on the file. Let's have a look at an example of that. I could simply type in that example that I showed you on the screen just a moment ago, who type redirect into user list. Now we don't see any output on the screen, but if we cat the file called user list, we find that it contains a list of users on the system. Similarly, I could do the same thing with any other command like ls, and I could pipe that into a file called file list, and then if I cat file list, I find that it contains a list of files in the current directory. Now I'm not going to go into that in any more detail because, as I said, it's knowledge that you all should have already. Instead, I'll just move on and show you the rest of the features that I would also hope that you would already know. Very similarly to the first option, standard output can actually be appended to the end of a file rather than creating a brand new file. To do this, you use the double greater than signs. For example, I could append the contents of the etc password file onto the end of my existing user list file by simply using the double greater than sign. Let's do exactly that. If I cat /etc/ password onto the end of my user list file, I can now, I'll just do a little more on user list, and I find that the first couple of pages of it are a list of who's logged in, and then I find the actual contents of the etc password file, which is actually in fact a list of all the users on the system. Okay, so that's a little demonstration of the double greater than sign. Moving right along, it is also possible to what we call pipe the standard output of any program to the standard input of any other program, assuming that that other program actually takes standard input. For example, the who command could be piped to the wc command if you wanted to find out, let's say, in this case, the number of users that are currently logged into the system. Let's have a look at that. Who pipe to wc-l, and we find that there are 48 users currently logged into the system, including me. Now, for the pipe command to actually work, one of the programs, the one before the pipe symbol, has to create standard output, and the second of the two programs, the WC in this case, has to require standard input. Standard input, if you're not familiar with it, usually comes from the keyboard. So if I type WC by itself and just press enter, then it sits there waiting for me to type something. So I can type a little bit of nonsense on the keyboard here, and then finally when I press Control D, just so that you all know, Control D is the character in Unix, in all programs in Unix, that means I have finished typing, there is no more input. You can also think of it as the end of file character. So I type Control D, and then WC gives me the number of lines, words and characters that I typed. It's even possible to combine all these things together and say who pipe to WC and send the output to let's say a user count file like that. So now we have a file called user count. As you can see, that will simply contain a count of the number of users in the system, along with number of words and characters as well, which will be meaningless information, of course. Also, similarly, it is possible to use the less than character to redirect standard input from any file into a program. An example of that might be if you had a script that required the user to type the answers to several questions. And if you wanted to automate the running of that script, you could put the answers to those questions into a file, and you might call that file answer file, and then you could redirect the contents of that file to the standard input of the script that you're running. So when the script asked a question and used the read command inside the script to read something from standard input, it would actually get the input from the answer file instead, and so the script would run without any user interaction. I can only show you a brief example of that. I've created a little tiny script called ask name, and I'll show you what's in it. It's just echo please enter your name, and then a read of name, so it will actually read something from the keyboard and then it will echo that name back out again. I've also created a little file called my name, which just contains that. Now if I run ask name by itself, then it says please enter your name, and I type in my name and it says hello. That's all very nice. And now if I want to automate that program so that it doesn't actually pause to ask me for my name, then I would run it as follows: ask name and get the input from the file called my name. And there we go, it says hello Mark Virtue. The program ran from start to finish without any interaction from me because all the answers came from the file. More basic knowledge that you ought to have: standard error is a separate output stream from standard output. In other words, programs can actually create two different types of output, and each may be redirected separately. Standard error may be redirected to a file using the two greater than symbol. For example, if you were to search using a program called find for a file called fred.txt, you might want to put all the results into a file called results, while you also might want to send any errors into perhaps a file called errors, and thus you would see no output on the screen whatsoever. I'll show you an example similar to that. If I was going to run the ls command and ask it to list the details of the file called userlist and the file called xyz, and I didn't have a file called xyz, then I would get an error message on the screen. So I get the error message xyz knows a file or directory, and then I get the normal message saying yes, well, there is userlist for you. That's his standard output, and the error message is standard error. Now I can do all of that again, but this time I send the output to a file called file list, and I send the error message to a file called errors, like that. This time I get no output on the screen, and if I cat file list, I just find that same standard output that I saw the first time I ran this program, and if I cat the errors file, then I find the error message that I saw the first time. So some of you probably weren't aware of that you can actually get two different types of output out of the same program, and they can both be redirected separately. It is actually also possible to redirect them to the same place if you use the 2 greater than ampersand 1 notation. Let me show you that. There is the file command that I just typed again, but this time instead of sending the standard error to the file called errors, I will this time send it to ampersand 1, which means I want the error output, output number 2, to go to the same place as standard output, output number 1. And so again I see nothing on the screen, but when I do a cat of file list, I see both the error message and the output message. Moving right along with other things that you may or may not know about, there is a special file on the computer called /dev/null, where any sort of output, either standard output or standard error, could be redirected if you don't need it. For example, if you were trying to find a file called mark.doc, then if you ran the following command, the results of the command would appear on standard output, while the errors would be sent to /dev/null, which means that they would effectively just vanish. Dev null is like a great big black hole. If you write some information there, you'll never see it again. Let's have a look at that. Here's the command that I just ran. Instead of sending it to file list, I'll send it to /dev/null, and now I get no output on the screen whatsoever. It is not actually possible to examine the contents of dev null because it is not a normal file. If I do an ls-l of /dev/null, I find that it is a special character device. I can tell that it's a character device because it's got the letter C as the very first letter of the ls-l listing. Also, it doesn't actually have a size. It has a 1,3, I think you can see, which is the major and minor device numbers, but I don't expect you to know what that means. Finally, and the last piece of shell basics that I'll show you, is that commands may be run asynchronously. To run something asynchronously means to run it in the background. And what that means is, if the program's going to take some time to run, then you get your shell prompt back immediately while the program continues to run. Which means, of course, that you can do a couple of things at once. An example of this is if you had a backup command that you wanted to run and you wanted to use the nohup command to run it. Nohup, incidentally, is a command that allows you to run any other program, and if you log off after you have started a program using nohup, then that program will not be killed when you log off. This obviously makes the assumption that you knew about the fact that if you're running a program and then you log off, then that program will usually be killed. You can use nohup to prevent that. Anyway, the purpose of this example is to show you that if you put an ampersand on the end of the command line, then you will get your prompt back immediately. And I'll have to give you an example of that. Suppose I run the interesting little program called sleep, and I say sleep for 1000 seconds, and it just sits there doing nothing. Now, if I wait long enough, if I wait for 1000 seconds, which I'm not going to do, then I'll get my prompt back. In the meantime, I'll just type Control-C, which will interrupt it. And now I'll type the same thing again, sleep 1000, and I'll put an ampersand on the end. So it's still going to sleep for 1000 seconds. That program is still going to run for quite some time, but notice I get my prompt back immediately. I also get a little number of output there, 16165, which is the process ID of the process that I've just started that's running in the background, and I can use PS to check that that is in fact running. There it is, 16165 is my sleep program. And in 1000 seconds of its own free will, that program will end, and then if I did a PS at that point, I would find there was only my shell and the PS. Okay, so that concludes the module on shell basics. I hope that you knew all of those things before. If you didn't, now would be a good time to go away and practice those.